Thank you for inviting me to share my some experience with you. Uh, I am basically a statistician by profession. So uh, we are trying to interface the statistics with some management activities, but we have to keep in mind that basically I am a statistician in my profession. So first I thank Dr. Banerjee for inviting me to share my some experience with you. And I don't know whether which background all the participants are. I think that you are coming from different say, subject areas. I will try to explain as much as possible to make you understand about the situation, but sometimes some quantitative techniques or mathematical techniques may I will explain. Some may feel that it is hard to understand. So now we will come to the idea. The idea you have chosen the data-driven management system. So nowadays we know that what is the importance of the data. We most of the times we find that nowadays there is a course, data science, artificial intelligence. But I have some objection about telling data science because when we are analyzing, there is no science or no some theoretical development. I will tell data technology. So basically, what we are doing nowadays, we are using some statistical tools, we are using some mathematical tools, and with the use of computers, we analyze that one. Nowadays, you find that the importance of data is very much in our society. We did not feel that one even 10 years back. But why? So because we find that the society becomes complex and complex, more and more complex. Right? When to analyze this complex situation, we need now the data analysis. So you will find that in every production and service sector, now we need some data analytics. So every day, in our every activity, a lot of data generated from different corners, and now the advent of computers, information technology, we can store that one. And now we try to analyze this data, and that data tells you what basically happened. Right? What basically happened. So I will just take a simple example. We always interested about sports and cricket. So suppose the scores of different, say, 100 matches, score of Virat Kohli given to you. Just seeing the data, we could not interpret anything. Then we have to analyze this data. And we have to get the inner side about the performance of Virat Kohli. We have to analyze this data from different corners, from different angles, and that analyzing that one, what we interpret, that is our idea about Virat Kohli. So now, every day in any industrial organization, or any workplace, the data generated. There is some difference. Everything is information. When I am talking, that is also on information, but it may not be the data. So the quantified information is the basically data. So that data we have to analyze. And nowadays you will find that the big data analysis. That means voluminous, huge data that we have to analyze. And 10 years back, 15 years back, we analyzed this data manually. But now the volume of the data is, voluminous data is there. We have to analyze that one, and computer comes into the rescue operation. So this data now every sphere we need the analysis of this data. Generally, these organizations are under the AICT, other organizations are under UGC, and Ministry of Education. Nowadays, they did not physically go to the inspection of any institute. What they are telling, you send this data, you send this data, you send this data, and just sitting in Delhi or some offices, they analyze this data, and on the basis of that analysis, they got the idea what is going on in this particular institute. And accordingly, the funding planning or funding scheme and other schemes, they will decide on the basis of that one. So nowadays, hardly you will find they are coming to the physical inspection. So now, in today's turning point, we find that this data has a major role. And this data analysis takes a major central position for decision making purpose. Now, I will just try to concentrate on the quality management aspect. And if we think about, we are always conscious about the quality, no doubt. Okay, in my childhood days, I find that there is no concept of quality. In the market, only the monopoly is there. I find that at that time, only one toothpaste in the market, neem toothpaste. You go to the shop, you ask for a toothpaste, and they will show that this is the toothpaste. If you are not interested, there is no alternative. So it captures the monopoly. They don't care about the customer. Right? So there is no concept of the quality, and customer has no say. Whatever they produce, you have to buy them. If there is no alternative, then there is no scope to think about the quality, whether it is better quality or it is best quality or whatever may be. We could not think about that one. But nowadays, you will find there is so many competitive organizations there, and what they are doing, more or less in the same price, more or less, it may not be exactly, in the more or less same price, there is a competition who will give the good quality product to the customer. Right? So nowadays, we are conscious about the quality of any product, then the quantity also. So when we get there is 2 or 3 alternative same prototype product, we will always choose the best quality product, giving more or less same price. So this quality consciousness is now more and more since they are the multinational or oligopoly in the market. Now it is not the situation of monopoly. Hardly you will find any monopoly, but most of the times there is the oligopoly. So many competitors are there to supply the same prototype of product. Now then we are mainly interested about the quality nowadays regarding the products. So this quality management. But the question is, what is quality? May I ask you, what is your idea about the quality? Can anyone give you the idea about the quality? Even general idea. I am not asking any definition or anything. Can anyone tell what is quality? In your perception? No. So, I think we participants, we are not conscious about the quality of the product, right?
Benefit to human beings. Benefit to human beings.
Benefit to human beings. Okay, if I argue with you, most of the work what we are doing, to some extent benefit to the human beings. But it may not be a good quality in the sense, already it is synonymous good quality, not bad quality. Right? Good quality product. Right? So quality and good, it is more or less synonymous. We are not interested any time to get a bad quality product, good quality. But even then, I try to get some finer idea about the quality. Can you? Okay, thank you. You have given some idea.
Sir, it will be very different to product because the teacher's quality will be different, and the doctor's quality will be different, and the product quality will be different. A consumer product having multiple consumer products also we have. Depending on the consumer product also having different quality. So it will be based on the product actually.
It is basically satisfying customer need.
So it is customer need. Very good. So
maintaining a standard level.
Maintaining a standard level. So I tell you that this is a quality product. Whether you agree or not.
Sir, if we satisfy what the customer is demanding.
Just one by one. I try to make it interactive, right?
Sir, what the customer is demanding and what the level of quality the customer is getting.
So the confirmation of your requirement. So you have some requirement. You have some requirement, and whether it fulfills, right? It is one idea of quality, but sometimes I told that this pen is a quality, but you may disagree with me, and you may tell that no, this is not a good quality pen. Good quality pen should have some other features. Right? So this is first thing is quality is the one's perception or individual perception. My perception regarding quality may not be same with the perception of others. Right? So then the question will be, it is relative. Right? It is relative. Which is quality product to me, that may not be the quality product to you yourself. Right? So, first, rigorously, what we can say, the quality may be understood as the fitness for use. For what purpose I am using that pen? If it fits, then it is quality. Right? Number one. Another is the conformance of requirement. I have some specifications. I have some specification about that pen. The specification, sometimes you will find that some pens are of that amount of length. Right? So it may not be easy to handle. Sometimes I will find that few days back a pen with first I cigarette, just open and this is the pen. So this is length is very small. So sometimes it is not easy to use that one. But it may not be easy to me, but it may be easy to you. So it is the individual's perception, right? Then the question is, we, those are data scientists, nowadays it is called, but previously it is called that a statistician or something else. There is the problem. What is the problem? Problem is that the answer we get regarding the quality or the understanding we get regarding the quality, there is no quantification. Right? No quantitative character we have explained there. If that is the situation, then the data scientists are handicapped. Right? They are of no use. Because until or unless some quantitative characteristics we get, until or unless we get some numerical data, numerical figure, the data scientists or the statisticians can't do anything. Can't give any interpretation regarding the situation. Then the need is we have to try to define this quality in terms of some quantitative nature. Some quantitative nature. So now, first our aim is to this quality should be transformed into some quantitative nature, and then we have to analyze that. Next, so I told you that this concept of quality, the basic idea I have told you that fitness for youth. Some persons are like me. I am not so much of high thinking about getting something. I am satisfied. Okay, if it fit for use of for which purpose I am using, then it is a good quality product. So the fitness for use in 1950s, Joseph Juran give that understanding of that idea. That quality is the fitness for use. Now, in 1970s to 1980, Phoenix Crosby with that idea that conformance to requirements. I have some requirement about a particular product, right? So, if I use this shirt, then there is some I have specified some requirements regarding the shirt, whether it conforms or not. If it conforms, then we will find that we can say that it is a quality product. So, in 1970 to 1980, Crosby gives that idea that conformance to requirements. But these two ideas, there is no reflection of quantitativeness. Until or unless we change this idea from qualitative idea to quantitative idea, we can't analyze anything. So then, the idea given is regarding the quality, any characteristics of the finished product or the intermediate product or the raw material which is of interest. So if there is some plastic powder we use, so this is the first vendor who is preparing that. So it is the raw materials or the incoming materials for manufacturing that. Interest is regarding the quality of this plastic powder. But to me, the interest about the finished product. I am not interested about what intermediate quality products quality is. But who is just manufacturing this part? Who is manufacturing the refill? These are the intermediate parts. So, those are producing that these different parts. So, these intermediate stage, they also about the conscious about the quality. And then we will try to find out a character which causes the quality of that product. So then, for a particular pen, we can think that this length is one character, this diameter may be another character. If the diameter is big, then it is not easy one to use that. So different characters or chemical composition. So these characters of any finished product or intermediate product or the raw materials which is of interest, that is the quality of the product. Right? Next. Now this quality, we have to assure this quality. Right? We have to assure this quality. Now, what are the different approach? Generally we do use in engineering and management. Basically, it starts by ISO certification system, International Organization for Standardization. So, basically, they will inspect your system and your product that you are producing, and on the basis of that, they will certify whether your organization, if it is manufacturing organization, whether manufactured products are of good quality or not. If it is service organization, if you are rendering some services to the society, whether this service is of good quality. So they give that certification. So it starts by ISO 9000 certification, basically for production organization, ISO 14000 certification for the service organization, and nowadays, just recently, it is ISO 21000 certification. This is basically for the IT sectors, because now IT sectors is another area. They are the security system, the cyber security and others, so many things involved there. So this organization is certifying these IT sectors or IT business companies. So for that, we will find that ISO 21000 series nowadays. So they basically certify. We will find that when you purchase some product, there is a label. Sometimes it is written that it is ISO certified. ISO. So they are basically certifying whether the product that goes to the customer is quality product or not. But then we will get some the idea of total quality management. So quality is not only one part of the organization, because your employer, they should be quality, good quality employee or employer. Then the machines that you are using, that is also good quality. The total system also good quality. Then only you can get a good product. Generally, you will find that why we opt for some IITs, some IIMs, or some other organizations, because we find that their systems are good, the process is good, and it is our assumption or thinking that if some products, in that case in educational institution, the students, if they go through that process, the output will be good. I don't know whether the input itself is good or bad. The idea is basically, if the input goes through the process, that process is good, then it is expected that the output will be good. In case, most of the cases it happens. Generally, those are the outputs from this good process, 90 to 95% outputs are good. But very few proportions should be bad, but most of the cases it is good. That's why this ISO certification system or total quality management approach or this the Six Sigma approach or in organizations or manufacturing organizations or service organizations, we apply the supply chain management system. So these are basically process driven. So basically they look into whether the process through which this production is going on or service is rendering, that is good, or if it is good, then it is expected that the product coming out from that process will be good. So this is the general science, and their motto is that. Then we come to this Six Sigma approach and the supply chain management approach. So everywhere the motto is to rendering the good quality service to the society or the supplying the good quality manufactured product to the society. Next. So I just mentioned, again I told you that the main emphasis is on in ISO certification is that first is the process approach, then is your quantification, right? Just how the process is good, this is not only the criteria. You have to quantify that one and you have to keep the record with you. Nowadays it becomes easy because computerization system, you can keep the records easily and therefrom you can retrieve the data and then you can analyze. So this ISO certification main emphasis is on the process approach. Then another thing is the quantification. So you will transfer the situation from qualitative angle to quantification, quantify that one. And until or unless you quantify that one, you can't analyze that. So then for this purpose you have to keep the record, right? So that's why nowadays in every organization we are more giving more emphasis to keep the records. If you go to your higher administration or then he or she will tell that, okay, show me the record, then I will just say believe that you are telling the truth, otherwise no. So now we are not interested about just getting a vague word from you and you are telling that, okay, that happens, that happens. No. We need always the records to verify that one. So in ISO certification, the main emphasis is basically the process approach, quantification and record keeping. Next. Now we come to the total quality management approach. I told you that quality is not from just only one junction. The quality from every sphere, every junction. Right? Then, what are the principles of this quality management? First is delight the customer. So, in my boyhood, there is no concept of that one. The manufacturing organizations don't ever bother about delighting the customer. This is the product. If you either you purchase, I don't care about that. But nowadays, since there is a multi-corner competition, to sell your product in the market. So always the approach should be to delight the customers, right? Then I will come to that. Customer is not only the outside customer. You have some internal customers also, right? In your organization, every employee is an internal customer. But what product we are selling from the manufacturing organization to the outside, they are the external customers. So only satisfying the needs of the external customers is not total quality management. If your internal customers are not satisfied, they are not producing the product or giving the service wholeheartedly, then the good quality product can't go to the external customers. And then management by fact. You have to keep the record, you have to and you have to make it quantified, and that so just I am telling that this is the output of this process. We are not interested about that nowadays. We need the fact behind that one. So management by fact. Then the people-based management. So we have to be the customer-oriented management should be there, right? And then continuous improvement. So always your aim is to continuously improve. Suppose you have improved one side, then you will find that another side is in the lower rank. So then you have to improve that one. So there is always room to improve that one. And that's why you are using Pareto analysis, then histogram, so and so forth. So tools are there. Those you are doing that activity, you will find that this analysis will use. Next. I give a idea of this total quality management. The basic thing is good leadership of any organization. So whether it is the quality management side or production management side or whatever we do, the first and foremost thing is in any organization is the good leadership. So this is the base. And if we find that it is a pyramid structure, the first thing I told you that the customer delight customers. So it has two aspects. One is your internal customers are here. So basically you will find that those basically manufacturing the products in your organization, they are the internal customers. So you have to think that they are the real people who will add the quality to the product. Right? Then another is your customer satisfaction. The external customers, those are using these products, they will be satisfied, or they will be not only satisfied, they will be delighted. So then we can ensure about the quality of the product. Then we find that management by fact. So every work, even today, I am delivering lecture, you are attending that work. This is also every work. We can say that this is a process. So all work is a process, and another if every work is a process, there is information generated, right? So that information, some could be of quantitative type, some may be qualitative type. So this quantitative type, we have to measure that one, right? And then we come to the people-based is management. And so basically the people make the quality. So until or unless your customers tells you that it is a quality product, then it has no value. So the people will ultimately say that whether the product is of quality product or not. And then to do that one, we need the teamwork in the organization. So just my team has done the work tremendously, or in good satisfaction, but another team lacks. Ultimately, the good product will not go to the customer. So this is the teamwork we need. And then continuous improvement. So in continuous improvement, two cycles are there. First one is the prevention. So sometimes we call that prevention is better than cure. So first, what we will do, if there is any problem, just you prevent that one or you stop that one. This is one type of indirect improvement. And then when you generally we give some medicines for some disease to prevent that one, thus stop that one. Then we will give the medicine for improvement of that disease. So the first thing is prevention. So it is in indirect sense is a improvement. And then another point is your continuous improvement cycle. So if you find that there is 5 or 6 components for improvement of a particular product, if you do the Pareto analysis, you will find that you take some necessary steps and you find that its quality is better, then some others will be lower than that one. So when one gets better, then you forget about that one. The next component's quality you have to improve. So always there is the option or room to improve the quality of the product. Next. So these are the things that I just mentioned you. Now next. Next, there is the idea of Six Sigma concept. In Six Sigma concept, basically it is more or less just some improvement over this total quality management. In this concept, first tells that you define what basically you are going to manufacture in your organization. So you plan what you are going to manufacture in your organization. Or if it is service organization, then what type of service you are planning to render to the society. So this define, then the concept is major. So when you define that one and you start producing that product or giving service, then you have to measure that. So, and when you get some measurement, you analyze them. Right? So, by that way you can ensure the quality. So, you analyze that one. When you come to the analysis part, then you have to go to the data-driven situation and you have to analyze from different angles on this data. Then improve. So, what we will find in the total quality management, there is improvement. So here, when you analyze the data, where you will find that there is, in this place there is a lacuna, then you have to improve that one. When one sector gets improved, automatically, relatively, another sector, you will find there is something lacuna, then you improve that one. So, always improve and then control. That means we keep or hold this say quality situation as much as possible. So that's control or monitoring that position. So this is the concept of Six Sigma methodology. There also you will find that you have to analyze, you have to measure, and then you have to analyze. So always there is the place of data analysis. Next. Nowadays we are finding that in total system, the supply chain management, from planning or sourcing, then production, then warehousing, then go to the market. And even if after sale, what returns we are getting. So total system is analyzed in this supply chain management. Next. So these are the basic plans. Though you are involved in management education, you may know these things. Plan, like define in your Six Sigma methodology. Then source. What are the different sources where from the inputs are coming or intermediate inputs are coming, where we will house it. For incoming materials there is in-house, in-warehousing. For outgoing materials there is out-warehousing. So that where we will place that one. And in that case, there is the concept of comes the problem of inventory management. So when you manage this warehousing situation, then the problem comes of say inventory. And when there is a problem of inventory, you have to go by the quantitative analysis, and then you have to find out how much optimal quantity you can store in case of your in-warehouse or out-warehouse. So, and then make, if it is your manufacturing organization, then you will make that one. And if it is service organization, you have to collect the products from other places, and then you have to render that service to the society or the customer. Then you deliver. So, in case of your production organization, from outhouse warehousing, you will send the products by transportation system or other approaches. You will send this to the retailers or directly to the customers that deliver, and then what is your return? That analysis should be there. Ultimately, what is the aim of any industry or any organization? What is the revenue generated? What is the return we get? So, everything is in supply chain management, but there is also some pockets where you have to go to the data analysis technique, and analyzing that one, ultimately you will enhance the quality of the total system. Next. Now we come to the life cycle of a product. So if you look at the life cycle of a product, the first phase is your mission phase, or we will call the concept phase, or if you look at the total quality management aspect or supply chain management aspect, there is the, basically we told that define. So we will get the concept for the particular product that we are producing. So what should be its length? What should be its different dimensions? Everything we have to get about the concept of that particular product. Then, when we find that, or when the management decides that that particular product will be manufactured in this organization, then you have to go through the designing of that product. So in that designing part, basically the engineers take part and they will do the engineering design, and on the basis of that design, the manufacturing generally is done. So even this second phase is your designing phase. So in this designing phase, the basic or major roles are taken by the engineers in different segments. There is some role of designing of experiments part, where the data scientists or the statisticians have role to find out the optimum design or particular experiment. So every manufacturing organization or every manufacturing activity is nothing but experiment. So how will design the optimal experiment? Optimal experiment. So this designing phase. Then we come to the manufacture cycle. Then we come to the manufacture phase. Actually, on the basis of the design that has been made for a particular product, after manufacturing, we will see whether it conforms or not. So this we call that manufacturing phase or the conformance phase. And then, okay, we manufacture the particular product according to the specification fixed by the either say engineer or by the customers. We take the customer's view from say survey, and therefrom we transform that one by the engineer, the specifications, and whether that specification is conform or not. Okay, the specification conforms, but it may not. It may be that the performance is not good. Sometimes you find that ISRO prepare the satellite. Every specification is made, but at the time of launching, we find the defects. Right? So before launching, every specification we test, we check, and everything is okay. So conformance phase is okay, but performance may not be up to the level. So then the next phase is performance phase or service or use phase. So everything is okay, every dimension is okay, but when we are going to use this phase, it is not functioning properly. So these 4 phases or 4 cycles we will find in any product. Next. Okay. Now, what we will find that this quality of the product depends on basically these 3 things. Number 1 is quality of design, performance. Right? What specifications we have given, whether that or what requirements we have specified, whether it conforms or not. So, if that one is conformed, then the quality we expect that the product will be of good quality. Then ultimately the performance. If the performance is good, then ultimately we will say that the product is ultimately good quality product. So this three phases mainly depends on giving the good quality of the product to the society. Next. We are going to break for some time. So we may start that one and then there is some variation. Sometimes it is explicitly visible, sometimes you have to go to the microscopic view and then you will find there is some variation. Variation is inevitable there, right? Even if you toss a coin, right? And again you toss a coin, the repetitive job, there should be some variation. Sometimes we may explicitly measure it, or sometimes it is implicit one. So now we will find that what are the sources of variation, the products that are produced in any production system. Now variation exists in all processes. The variation can be categorized into two. One is your common or random causes of variation, and another is your assignable causes of variation or detectable causes of variation, or we call it preventable causes of variation, because if you detect that one, then there is some way to prevent that, right? Sometimes you find that cancer was not cured, but when we find, detect cancer, then after few years research and experimentation, now there is some systems we get to cure that. So it is sometimes we call that if there is a problem, there is a solution. If there is any causes of variation that we can detect, then we can prevent that. So the two types of variation generally we will find in any manufactured products. Another is your random causes of variation or chance causes of variation, which we can't detect. Right? You take utmost care to produce some product or to do or finish a job, or some have the hobby of cooking, so you are preparing some foods, you take utmost care, but you will find the variation which you can't detect for which reason this variation is. So that is called the chance variation or random variation. So common or random variation should be there. What could be the random causes that we can't identify? Right? And this is unavoidable. Whatever precaution you take, unknowingly it will happen or it will be there. So unavoidable. Example for slight differences in process variables like diameters, weights, service time, temperature, and so on and so forth. Right? Then we come to the assignable causes of variation, and we call it detectable causes of variation or preventable causes of variation. So that cause could be identified, and if we can identify, we can eliminate in some way. Say example for poor, where from it comes the poor employee training, or some machines need some repairment, and for these reasons we will find there is some, we can detect or we can find out that what variation we find there. Next. Then chance of common causes are small random chances in the process that cannot be avoided. So if we draw the histogram of the data, of the measurements we have, and that histogram we just connect by a line, then we will get the variation structure of that type. So this spread will be there, and this variation, I call it inevitable. We can't detect for which reason this variation happens. So when this type of variation is suspected, production process continues as well. So there will be no overhauling or there is no stop of the production process, because we can't detect what type of from which sources of variation it is. Next. But if we find that these, say, chance causes of variations are superimposed, 2 or 3 or 4 different chance causes of variation, then the accumulated effect we can identify. So that then we will say that this is the assignable causes of variation. And if this assignable causes of variation is present there, then we can identify, and when we get so many assignable causes of variation, then we can take the average of these values. So we can say that this is the representative value of detectable variation or assignable variation. So this mean or median or mode, these are the measurements by which we can measure the assignable causes of variation. But even now you come to the measurement part. So we can measure that one by using some averages. So that average will give you some idea of assignable causes of variation, or we call it say detectable causes of variation. Next. Then another, I told you, another thing is how we will measure the chance causes of variation. Because what is the reason for variation we don't know. But unknowingly there is some variation taken place. But how do we measure that one? So this is in your quantitative techniques methods or in statistics we measure it by the variation or variance or its square root, which is called the standard deviation. So this spread or the sometimes we use by the range of that measurement that gives you the one measurement of chance causes of variation. Next. So these are different structures of your assignable causes of variations are there. Next. Now we have to monitor for each product that are produced in any organization. This monitoring or control, we do it by basically two approaches. One is your process control approach, another is your product or lot control approach. So I told you that in your ISO system, in your total quality management approach, everywhere the main emphasis we have given on the process, whether the process is at the control state or not. So here we apply two approaches of controlling or monitoring. Number one is your process control. That process control is achieved through mainly the control chart technique. Control chart technique. And another is your product control. That means the particular products that are produced, whether these products are of good quality or not. Okay, the system may be good, its different nodal points is good. But even if you will find 5 or 10% bad students are coming out from the good institutions. So, the process good does not give you the guarantee that all products will coming out from that process will be good. So, there is a need of checking whether the products coming out from that process is good or not. So, that is done by your product or lot control technique. And so, this is generally achieved by using the sampling inspection plan. That means the products produced, if the production is voluminous, then every product you have to check its dimension. Impossible. It is economically not viable. It will take time, so time consuming. So from factory point of view, from manufacturing organization point of view, every product produced, that will be checked, and then we will certify, not possible, and then the organization will ruin, right? So, what basically we will do, from the products produced or manufactured, out of that voluminous product, we will take some sample. And on the basis of that sample, the decision we get, our basic assumption will be that this is the criteria of the whole lot itself. Right? Nowadays, you will find if you go to the market, if you try to purchase rice, you will get the packaging rice is there. But a few years back, we go to the open market and we purchase rice. What is the sampling technique we do? Just we go to the in front of the sack, just push your hand, you take a handful of rice and then say, oh, it is okay, you give me 5 kg of rice. So, this is the sample checking because each rice of the sack not possible to check or whether good or bad. So, this achieved through the sampling inspection plan technique. Next. Now to check the process, whether the process is under control. Under control means it is in okay situation. To check that one, what basically we will do, suppose for the whole day in your organization or in your factory, the production is going on. Right? Suppose you are in your factory, the soaps are produced, right? So then how you will collect this sample? Suppose at the beginning stage, first hour, we take some sample. Then after 2 hours or 3 hours, we will take some sample. Then after another 2 years, you will take some samples of the size 5 or 10 or something. And then in each stage, the subgroup we collect, that we will call the rational subgroup. Why it is rational subgroup? Because the basic idea is that at that time point, what products are manufactured, they are qualitatively more or less same. There is no such difference as is. But after 1 hour or 2 hours or after 3 hours, we take another sample and this sample as if homogeneous. That means there is no difference. But difference, if there exists, from first time point sample to this time point sample. Why it may happens? If there is some fault in the total system, then it may be may change, or due to temperature increase, there may be the change. So many reasons are there that should be identified by the engineers concerned. But that's why we are telling that at that time point, what sample I will take, it is called one subgroup. Then next time point we will take another subgroup. It may be in different time points or different space. That means suppose we have 5 factories, right? At the same time in different places the production is going on. So I will take a sample from here. So the production that is going on here, we assume that there is no difference among them. But another location, there is another factory, and there the production is also going on, and we take a sample. So our basic assumption is that in that place there is no difference between among the products that are produced there. So if there is any difference between location to location, right? So so the sample that we collect here, I call it one subgroup. The sample we collect another location, that is another subgroup. So we make different subgroups. So these rational subgroups or samples should be selected so that if assignable causes are present, chance for differences between subgroups will be maximized, while chance for difference due to assignable causes within a subgroup will be minimized. That means within means in the this place or this time point, and between means from this time point to this time point or this place to another place. Then we come to the what is the basis of I already mentioned that basis of subgroup formation. Sample produced at the same time in different places or different time in the same place, right? So and sample representing order of production. Generally what happens in the BD hour, the production may be one type, in the idle hour or some other times it may be different. So subgrouping may be in different way we can look into that. Okay. I think probably the problem is from system. People. Next. Okay. So then there is we use the control chart techniques to check whether the products that are produced in a particular process, that process is of good or not. How we will check? We will check on the basis of the product that are produced from the system, because there is no way to check the process itself. The process generates some products, and on the basis of the characteristic study of the products, we will conclude that the process is under control or in control state or not. So this could be of two types. One is your control chart for variables, another is your control chart for attributes. What is attribute character? Suppose color, say red, that many of items, blue, that many of items, yellow, that many of items. So your character is not numeric, but the frequency, the number, that is numeric. This is your attribute character. In case of production, what could be? We can categorize. Suppose I see a handful of rice. Okay, good. One category. No, it is bad. Another category. Right? Or engineering products. Okay, it is defective one. One category. It is non-defective one. Another category. So These are the categorical data or attribute data, right? These characteristics have no numeric value, but the number, how many times it appears, that is numeric. So we can get the frequency of that. Another is, you just exactly get the exact measurement. If we take the measurement of that one, that will give you, say, that much of inches or that much of feet or whatever may be. So you can get the exact measurement, and that is numerical in nature. That is quantitative in nature. That in our statistical language calls the value, right? In engineering aspect sometimes we call parameter, but here in statistics language we call it value. So this, when we will get the exact measurement of any characteristics, then we call it the variables, and the control chart for that variables. Sometimes we will use the mean chart, that means X bar chart or mean chart, to monitor the changes in the mean of a process. Though you have some statistics background, or not necessarily they will come from the exactly statistics background. Though they are in commerce background, they have gone through the statistics. Though they are economics background, they also go through the statistics. Though they are mathematics background, they also go to some extent statistics. So even in philosophy, you go to some statistics. In everyday life, some primary statistics we use. Average, mean, that we can use. So this X bar chart to monitor the changes in the mean of the process. Another is use range chart. Why it is? Because you find that in industry, how easily we can use that. I told you that we are in industry, though we are from heterogeneous group. So always taking all these measurements, calculate its means or calculate its standard deviation sometimes may create problem few days back, but now it is not problem. You have the calculator, you go to just this one, and then you put the values, it will give you the value. There is no problem. But 10 years back, we faced that one. And another thing is how easily we can do that. Foremost thing is, in industry, when we are doing that job, that much of theory, that much of calculation, we are not interested. We are interested to get as easily we can use calculate that. So then, range is another measurement, which I called you that the one type of variation we can measure. And what is that one? It is easy to calculate. Suppose there are 10 measurements. Out of these 10 measurements, you just find out the largest value, and then you just find out the smallest value. So largest value minus the difference between that gives you range. So it is comparatively easy to calculate. Otherwise, sometimes I have the feeling, even say in science backgrounds, zoology or botany students, they find very hard to find out even mean also. So you calculate that one, then averaging out or calculate the standard deviation. It is very difficult. What these people are doing that one. So how easily we can calculate that one. So this range is comparatively easy to calculate. And using that, sometimes we prepare the chart, which is called range chart or R-bar chart. So these are used for checking whether the process is under control. The system can show acceptable central tendencies, but unacceptable variability, right? Next. Now, you find, I will not go through, just ask you to calculate that. Because, just in the key table, I mentioned that one. Because all will not calculate. Okay, I have to get the idea that this is your control chart, and in my industry I find that in this production process, whether the process is controlled, we will check that one. So, I may be a history background people, so it is not my job to calculate that one. I will tell that, okay, say quantitative technique people or mathematics people or those are trained in statistics software or statistics background. I just ask them that you just calculate the X bar chart and show me what is the picture, and on the basis of that the higher management will take decision. All the times the higher management will go through the grassroots level and do that activity. It is not that. This is the situation. Then what is the job of the other people in that organization? So every people has some job. So what generally we have? Suppose this is a representative X bar chart. What are the three lines we will find? This thick line, straight line, is called central line. That means our expected value should ideally will lie on that thick line. But it is ideal situation. Reality is not ideal situation. I told you that when you perform anything, then there is variation is inevitable from one product to another product, same product, but there is variation. Then the mean or the central value should must lie on this central line, but reality does not permit that. In reality, what happens? It will. Our expectation is that it should be around that line. It should be around that line. Then, on the basis of that measurement, we will try to calculate two different lines. One we will call the lower control limit, another we will call the upper control limit. So, these two dotted lines, the below one is the lower control limit and this one is the top one is the upper control limit. How it is calculated? In 1865, Dr. Walter Seward, first in Britain, he has given that idea of 3 sigma control limit. 3 sigma control limit. It has some statistical and mathematical background. I will discuss that one. But on the basis of that, we make these two lines. The products that are manufacturing in a particular organization, and we take the subgroup measurements and their mean values or the X bar values we calculate for each subgroup. And if we find that the production, this process is in good condition or controlled situation, then our expectation should be lying between this lower limit to upper limit. Sometimes you find that those are civil engineering background, they say that, okay, the measurement is this one, but changes may be plus minus 5 centimeter or 6 centimeter. So, these are the tolerance limit. So here, ideally the value will be on the thick line, but due to this fluctuation, inevitable fluctuation, we can tolerate this fluctuation up to how much? From lower level to upper level, control limit, these two levels. If it goes beyond that, then we will suspect that what products are produced through this process, the process may be faulty, otherwise it could not happen. Because the product is coming out from that particular process, and if we say allow some fluctuation, then it will lie between these two dotted lines, lower control limit and upper control limit. But if it goes beyond, that means above this or below this, then we have another justification that the process is not under control. That means there is some fault in the process through which the product is manufactured, right? Then, okay, quantitative techniques people or we have no role, but we will just give the indication to the engineering section that there is some fault in the process. You go for search for that one or you hunch for that one and then you take the remedial steps. And at that time point, if needed, the process halt should be there, right? And then they will take some action. Then after that, again we will start the production and then we go to the checking of that one. So these points are basically the expert values for each subgroup that we have calculated. And we plot that one, and in this particular graph, we find that it lies between these two dotted lines. Then our conclusion will be up to that point of time, the process is under control. That means we may proceed for manufacturing the products, right? Next. Then sometimes we talk so many theories, but practice is different. Okay. If we go to the control chart, variable control chart, for each subgroup, you have to take the measurement exactly. Then it is time consuming and cost effective. Sometimes you find that for testing purpose, we send it to the testing center or test lab. After 2 or 3 days or 5 days, they give you the report. Then what happens? If ultimately we find that the production process is out of control, that means for 3 or 4 days, what production we have done, that is of bad quality product. Already production is continuing, and while we are manufacturing not for storing, we are manufacturing it for selling to the market. So we sell it to the market, and then there is from the market there is bad reports, and after some days it may be very difficult situation for the company that the brand name will go, that this company is supplying a bad quality product to the market, right? So that's why sometimes to get a at a glance situation, we go for the attribute control chart. What generally we will not go through the exact measurement of that. We just go to eye checking or some preliminary checking, and accordingly we segregate the products whether they are good or bad, or say defective or non-defective. So then, so this is your attribute type character. Then in that attribute type character, what we can measure? We can measure the estimated proportion of defective or estimated proportion of non-defective, right? So this P is the proportion of defective, and that's why we call it P chart, or sometimes in our colloquial language we call it yes or no, or good or bad chart, right? So use a P chart for yes or no, or good or bad decision in which defective items are clearly identified. Nowadays, so many packages are there. We start by Excel, a spreadsheet, SPSS, Python, probably Dr. Banerjee had discussed that on, our software which is freely available on the website, we did not need to purchase that one. Nowadays we get Jamuvi. So many packages are there. And there you may get this charts. You just you get the data and input that one, then they will show you the chart. So that's why I am not going to exact calculation of that. I am just giving you the idea where we can apply that one, what type of tools we can use. Then either you can use software or you can take the specialized person who is specialized of doing this calculation and others, and they will do that one. We being the managerial person, we will go to the picture and we see that, oh, this is the scenario. So accordingly we will take the decision. So decision basically we are taking on the analysis of the data, and therefrom the picture comes out, and on the basis of that we will take the decision. So then this P chart, or yes or no or good or bad chart, another type of chart is your C chart, which calls sometimes not the proportion. Sometimes suppose some are in some organization they are say manufacturing some metal sheets. Then they may be interested about the character, how many spots or defects lying on a metal sheet, on a particular metal sheet. And these defects definition will differ from one organization to another organization. Sometimes I may find that on its surface this is not a defect, right? But some other people, sir, may ask that no, it is a defect, right? There is some spots and something. So that defect definition would be defined by the corresponding organization's management and the people concerned related to that analysis. Then if we find count the number of defects on this sheet, and this defect is also qualitative characters, not quantitative one. So on the basis of that, the chart we can draw is called the C chart, or number of defects chart. So use C chart for more general counting when there can be more than one defect per unit. So where generally these are some examples: number of claws or strings in a carpet, sample cut from a production run, number of complaints per customer at a hotel. So in a hotel there is a logbook, the customer complaint is there, then we can count the number of complaints. So this could, using that, we can draw the control chart, say number of defects chart or the C chart. Now we come to the process capability study. We find that we are producing the product in a particular process. The products that are produced, that is supplied to another organization. So they have a demand of the products, and the supplier who is supplying that product, whether that organization is capable of supplying the product of the needs of the organization who has demanded the product from your organization. Obviously, according to their specification, right? I discussed about told about the control chart techniques, but there is no say of the customer. Being the producer, I produce the product, and I take the measurement, I draw the histogram, and there I will get the picture that this is the character of the produced product. But there is no say or no voice of the customer. But in practice, what generally happens? It is customer need-based organization should, right? So generally, what we do, we go to the market survey before launching any project, and what is their basic needs? According to the needs, we try to reflect our manufactured products in the defined phase or concept phase. Now, here we will try to bring the concept of the voice of your customer. So suppose for a particular character, customer has some option. Their lower specification limit is that one. Suppose a pen, its length, it may be that, okay, 5 centimeter is okay, but minimum, but 6 centimeter is maximum. Beyond that, it is not tolerable. So then, we call it the lower specification limit and upper specification limit, which is given by the customer or said by the customer. So now, if we find that, will you please go to the previous slide? This one. So, you find that this spread in the baseline, this spread is basically called the 6 sigma. 3 sigma plus 3 sigma. So this 6 sigma. So now, the manufacturer produced the product, their measurements, measurement may vary, but this variation will be from this end to the right end. So this is the variation part. So this is, we call it is 6 sigma, right? 3 sigma plus 3 sigma. Next, you go to the previous. Then the limit in the control chart, the 2 dotted lines, the difference, the spread between that is your 6 sigma. Right? Now the situation will be, you have a spread of your specification limits, USL minus LSL. Now we will compare these with this 6 sigma. Now, if 6 sigma is less than of that specification spread, then what will be the situation? Condition is ideal one, because my product produced its variation level includes the specification given by the customers or customer specification. So customer specification, suppose this place, and the products produced, if 6 sigma will be that one. That means we are over satisfied, our needs fulfilled, right? So ideal condition, the process will remain within the specifications even after some shift, right? If we find that one, then we may play a trick in the organization. Okay, we can relax to some extent. Then our cost will be minimal, our time may be minimal. Okay, we have that scope. The second situation is the process speed and the customer's specified speed is almost equal. Then it is as long as the process remains in control and center, that parts produced will be within specification. But a minor shift distort that situation. Right? Another situation is very great situation. If we find that we produce the product in my organization, their spread is that one, but the customer needs their specification spread within that one. That means some products goes beyond the specification of the customer. Obviously, if that happens and this product goes to the customer, they will not be happy. Right? So this third situation is that one. So undesirable situation, the process is incapable of meeting the specification. So that means the product that produced in that particular process is not capable of satisfying the needs of the customer. So this is called the incapable process. So management interventions is necessary in order to decrease that variation. Right? Next. Now I gave this pictorial view that the load specification given by the customer is the bottom LSL line. The upper specification given by the customer is top USL line. Then the C sigma limit is your green color line, right? Lower control limit and upper control limit. Then if that's the situation, then we have some scope to relax. And then in the previous situation, our aim was just, or our expectation was that the measurements will lie on that central line, but now it is relaxed from this band. If it lies in that band, then it is okay, right? Then it is okay. Next. Now we will try to calculate the process, the products that are coming out, we will calculate the process ratio. Right? So this is basically the voice of the process. Right? In the organization, we are manufacturing the products, we take the measurements, on the basis of that we draw a histogram, and if we join these lines, this should be the situation of the product's measurements. So this is the voice of the process. Next. This comes another step. So this is the voice of the customer, because customer needs for this particular product, the lower specification is that one and upper specification of that one. So then we will try to calculate the ratio between these two spread, and if we find that the spread of the customer need divided by the process spread, mathematically if we find that it is greater than 1, that means it is a good process from the customer's point of view. If it is approximately equal, then also okay, but there is a risk that sometimes we may get bad product. And if it is less than 1, obviously it is incapable process, because what customer needs, the manufacturer is not capable of supplying that according to the needs of the customer. Right? Next. Now, what basically we found, the measurements that we discussed is, we calculate for the measurements for each subgroup, and we plot that one. On the basis of that picture, we come to the decision what we are getting, or whether the process is under control or not. Now, there is no need of keep the say records in your memory of the previous subgroup, right? So that's why it is called the memory-less measurements. So first subgroup value we put there. Then we forgot about the first subgroup. Then second subgroup we find out the mean and we plot there. So there is no need of keeping the value of the previous subgroup's mean in your memory. So it is called the memory-less measurement, and these charts are, that's why it is called memory-less control charts. Now, sometimes you will find that first subgroup measurement and second subgroup measurement, they may be interconnected to some extent. Then, if we take some previous subgroups measurement into the present calculation, then it is called memory type measurement and memory type control chart. Now we will plot some cumulative sum control chart. So we will calculate the subgroup of the first subgroup, then we plot that one, then we take some portion of the first subgroup and the next second subgroup measurement and combine these two, and then we plot that one. That means we keep in mind the previous one observation also. This is here the cumulative sum chart, and that chart we have just plotted here. Now, another is your exponentially weighted moving average control chart. Our control chart, sometimes we are not making the subgroups, we are taking the measurements and first say 5 observations, we calculate the mean, then we exclude the first one and then we take the next one. So next 5 observations and therefrom we can calculate the mean. So if we do that one, then we calculate that one, and on the basis of that we calculate one measurement which is called exponentially weighted moving average control chart. Then the mathematics behind that one is your given here. Lambda is the ratio in which the previous observation we will take, because whole observation we will not take, we will take a proportion of that one, and therefrom we go to the mathematical calculation, and then ultimately we will plot the our control chart on the basis of z value. So for this exponentially weighted moving average chart, these limits this control line is your the target mean target value mu naught, what we have targeted, and then lower and upper control limits are these the mathematical expressions. Next. So this is the ideal graph that we have. Generally we visually see that one, and on the basis of that we will take the decision. So you find that in each time point we calculate the z values, that in the middle portion, and in the lower portion and upper portion, these are the lower control limit and upper control limit, and that will change on the basis of when we progress with the time. Then I have mentioned that one is your we change the process on the basis of control chart technique. Then another is your we change the product on the basis of your sampling inspection plan. Now, this branch of statistics, This is basically statistical quality control. Its branch refers to the process of randomly inspecting a certain number of items from a lot or batch in order to decide whether to accept or reject the entire batch. So generally, what happens? Your products you produce and then you make it different packets, and then we will check some items from each packet, and on the basis of that we will take decision. So different sampling, different statistical process control process is there because acceptance sampling is performed either before or after the process rather than during. So sampling before typically is done in supplier material. So what generally we do, when we purchase some product in my organization, the supplier, they will supply that one, and basically what we do, we will go for sample checking of that product whether it is up to our requirement or not. So the sampling before typically is done to supplier material. Sampling after involves sampling finished items before shipment or finished components prior to assembly. Right? So when we send it to the market for selling, before that we will check whether the product that we have produced in our organization that will meet the customer's need or not. So this is generally done after manufacturing your products. So use this sampling inspection procedure when we use where inspection is expensive, volume is high, or inspection is destructive. Right? Some cases the sampling inspection inevitable. Right? Suppose you will check whether the matchsticks that are produced in manufacturing organization, they are good or bad. If we go checking of every stick, then at the end, nothing. So it is mandatory that for destructive items, you have to go through sample checking. The complete inspection not feasible there. Next. Now, goal of acceptance sampling plan is to determine the criteria for acceptance or rejection based on size of the lot. So, if you make a packet of units, I theoretically call it capital A, then this is the size of the lot. Then size of the sample, that means as I mentioned that all items could not be checked. A representative portion is to be checked. So suppose this is your small n, say 5 or 10 items we will check. So small n will be your 5 or 10. So, and the number of defects above which a lot will be rejected, I call it C. We will call that this lot is defective lot. The whole lot is defective lot. Try to understand. Not only the sample, the whole lot having 1,000 items is defective. Then there is for the defective lots, the organization has different policies. Sometimes these lots could be sold in the reduced price. Sometimes if it is defense related product, sometimes these lots are rejected. So this is different, the decision of the organization, what their decision should be. But we will reject that one, the rejected lot. Level of confidence we wish to attain, right? So how much confidence level we will try to do this exercise of this say sampling inspection plan, whether 95% confidence or 90% confidence or that one. So, always 100% confidence, it is practically not possible, impossible. Sometimes we go to the 90% confidence or say 95% confidence. Sometimes we go to 99% confidence. So that confidence level we have to check. So can be used on either variable or attribute measures, but more commonly we use it for attribute type characters. Then this classification of this sampling inspection plan has two types mainly. The classification is made on the basis of the mode of submission of the product for inspection. One is lot by lot, that means form the lot first and then carry out the inspection. As I have told that for the products supplied by the vendor to my organization. If this is the situation, first you make the lot and then you inspect the product, whether on the basis of that you will take decision whether it is this lot is acceptable or not. Another is your continuous inspection precedes the lot formation. Generally what happens? Suppose in your organization you are say soap manufacturing company. Then your production in belt, the soaps are coming out. You just different time point you check, you take randomly 5 or 6 soaps and go to checking whether it is good or bad. And on the basis of that, you just take the production. If you find that it is good, then you make a lot and then go to the supply to the market. So this is your inspection precedes the lot formation. So these two types are there. Next. In lot by lot sampling inspection plan, we told there are two types. One is your attributes, another is your variables. Generally, we apply the attribute type sampling plan. So, in case of attribute type sampling plan, we use generally acceptance rejection type plan. What is acceptance rejection type plan? On the basis of the sample, you decide whether the packet or the lot of product or the packet supplied, whether you will accept this packet itself or you reject them or reject them. Another is acceptance rectification type plan. What is that one? Okay, we find that on the basis of this checking, it does not conform my requirement, right? But those suppliers have produced that one. If it is rejected by me, then it is total loss to them. But if we find that that production more or less we can use that one, then I can give some option to the vendor that okay, you just I can accept that one in some reduced price, right? Then ultimately we will accept, but after some negotiation. If that one happens, then it is called acceptance rectification type. Right? You time is how much? Whether I exceed that one? 20. Okay, you then go. Go. Is my pen right? Then generally what we find, whether the manufacturing items are under control or not, we find that there is two steps. One, we discuss about the process control technique, whether the process through which this manufacturing is done, whether the process is okay or not, that we will check on the basis of the products that are coming out from that manufacturing process, and getting its measurement, we draw the control charts, and on the basis of that control charts, we take decision whether the process is under control or not. When we find that this process is under control, then we will go to the inspection of the products actually coming out from that manufacturing process, and these products can be checked in two ways. One, first you make the lot, and then you check each lot on the basis of some statistical measures. Either we will accept the lot, or we will reject the lot, or we rectify the lot on the basis of the say policy of that particular organization. Another is in your organization, suppose you are manufacturing the product, then before making it the packaging or packet or lot, you go to the inspection and on the basis of, this is called the continuous sampling inspection class, and apply this continuous sampling inspection plan. After that, the good items, sampled good items, you put in each lot or in each packet and then prepare that packet and you supply this one to the market. Generally it is not immediately supplied, it is supplied to the out warehouse for storing purpose, and then according to the market needs that will be supplied. So this is basically the quality control or the conformance checking part. Another part is the performance of the service or quality of performance, which is your use part or service part. That is generally done in the using the reliability testing part, and that part is generally not done in your industry. It depends on how much time it functions satisfactorily. On the basis of that measurement, there is some procedure of applying the reliability measurement part, and if this reliability is more high, this reliability generally lies between 0 to 1, and if we find that this reliability is approaching towards 1, then we will decide that it is a good performing product. And these 4 phases of life of a product we have to study, and this totally covers this quality management aspect. And I mainly mention you the where the data has been is to be analyzed, and on the basis of that data we take the decision, not any vague idea. The mainly the decisions are taken on the basis of this data analysis. I just stop here because some things are there, but due to technical problem, it is not possible to show these big parts. Now, if you have any query or any questions or comments, you may discuss.